Today I will be presenting on the evolution of the definitive mammalian middle ear. The structures contained in the middle ear today, in particular the malleus, incus, and stapes, were not always there, but throughout evolutionary processes like survival and fitness advantages, these structures reside in the middle ear today. Throughout much research, it has been shown that there are multiple competing hypotheses as to how the definitive mammalian middle ear became the structure it is today. But one thing reigned true for all the hypotheses, and that it was connected to the evolution of the jawbone. During this presentation, I will talk to you about the developmental processes and evolutionary relationships that led to the formation of the definitive mammalian middle ear, and how it is directly linked to the formation of the jawbone. So, before I get started, I just want to give you a brief overview of what I'll be talking about today. First, I would like to reintroduce my topic, but go into a little bit more detail and then present my thesis. After I present my thesis, the next 5 topics I will mention will flow well together. Those 5 topics include the breakdown of Meckel's cartilage, and I will also go into talk about what Meckel's cartilage is. Then the connection between the quadrate and articular, 2 middle ear structures we know of. Then finally, the formation of the jaw joint. And lastly, the formation of the dentary, which ultimately will lead to the definitive mammalian middle ear. After those topics are explained with much research, I will highlight my takeaway points that will hopefully lead you to understanding this evolutionary process better. As I have mentioned previously, there have been multiple competing hypotheses over the years. When I say competing hypotheses, I mean that the overarching theme is that the jawbones evolved with the middle ear structures, but where these hypotheses compete or differ is in the fact of when in time these events occur, especially depending on the mammalian species. With that being said, the connection to the jawbone evolution is that there are 2 structures, the quadrate and articular, who are found to be directly linked to the middle ear structures, the incus and malleus. So, my thesis states the definitive mammalian middle ear evolved due to the ossification of Meckel's cartilage, the separation of the malleus and incus from the jawbones, and the formation of the dentary. So what is Meckel's cartilage? Meckel's cartilage is a prominent mandibular structure that is present in the early development of mammals. It functions in providing support and structure to the developing lower jawbone. Throughout this development, Meckel's cartilage will undergo a breakdown and then ossify to become the bony structure of the jawbone. So, when we look at figure 1, I just would like, these are showing embryos of a mouse and a chick. So I just want to do a little bit of comparison and kind of just point out the structures that I'm talking about. So in the mouse embryo here, this is labeling Meckel's cartilage. And as you can see, it is directly linked to the malleus. And here's the incus, which is still attached in this lower jawbone, just not directly connected to Meckel's cartilage. This is just showing middle ear structures that we know of, kind of showing their shape and how they're evolving. This then would be the chick embryo. So what I would like to note about the chick, obviously we know their jaw is completely different than humans or a mouse. But I would just like to point out that their function is very similar. So Meckel's cartilage is still going to help form that lower beak jaw bone that they have. And again, it's directly linked to the articular, which now we can point out that the malleus and articular are going to be homologous to one another. So these terms will be used interchangeably, as well as the quadrate with the incus. And again, formation of some middle ear structures. So as I mentioned, Meckel's cartilage will undergo a breakdown, which then will lead to an ossification. This breakdown occurs at different times depending on the mammalian species, which researchers have found throughout studies of embryonic development and after they have been born. For example, in mice, the breakdown of Meckel's cartilage occurs directly after birth, whereas in opossums, it occurs a couple weeks after birth. The ossification of Meckel's cartilage is what leads to the formation and the separation of the malleus and incus from the lower jawbone. This occurs after Meckel's cartilage is reabsorbed and ossified. It's important to note that when Meckel's cartilage becomes ossified, its posterior part is joined to the malleus. So again, just looking at chick and a mouse, these are not in embryos anymore. This is later in development. So as you can see in the chick, I just want to note that the homologous structures are the quadrate and incus, as well as the articular and malleus. Again, the malleus and articular are both connected to Meckel's cartilage, but comparing these two photographs or figures to one another, you can see that Meckel's cartilage has shrunk in the mouse versus the Meckel's cartilage in the chick is still very prominent structure. So that's an important thing to add. Now that I have given an overview as to how the jawbone is formed initially, this leads to two important structures, the quadrate and articular. So, the quadrate and articular are located in the jawbones. The quadrate is located in the upper jawbone, and the articular is located in the lower jawbone, as you can see from this rough sketch of a skull. So the quadrate connected to the posterior part of the upper jawbone, and then the articular located on the posterior part of the lower jawbone. Both of these structures function in hearing and mastication, that means chewing, and later on I will talk about how they will undergo evolutionary shifts to become the middle ear structures we know of today. And again, reiterating the fact that they are homologous to the malleus and incus. So the malleus is homologous to the articular, and the quadrate is homologous to the incus. Now that there's some background on what the quadrate and articular do and what are their functions, I think it's an important thing to note how they are similar to the middle ear structures, the malleus and incus. So, firstly, the malleus and incus were derived from cartilages, like Meckel's cartilage, which we talked about previously. This was found by researcher Reichert also when he dissected on pig embryos. And we looked at chick and mouse embryos earlier, so he also found similar findings in pig embryos. This is related to the quadrate and articular since they were also derived from cartilages. Finally, both the jawbones and the middle ear structures mentioned perform the function of hearing. The quadrate and articular were shown to perform bone conduction in order to generate the sound transmission, which is why we were able to identify their function in hearing. Now that we know that there's a connection between the jawbones to the middle ear structures, I would like to talk about the next evolutionary event that occurred in the jaw. This would be the formation of the jaw joints. So, first, the formation of the primary jaw joint occurred. This was formed by the connection between the quadrate and articular. This joint was formed in order to aid in chewing and hearing functions. Because this was the first jaw joint, this just allowed proper mastication to occur to the best of the ability at that time in the past. Next, due to environmental pressures like needing to chew bigger food, larger food, more of it, The secondary jaw joint was formed between the dentary and squamosal bones. This joint therefore allowed there to be separation between the upper and lower jaw bones, so no dislocations would occur when chewing. This helped aid in their survival. This was a survival advantage. This joint, because it mainly functioned in chewing, the primary jaw joint was freed from this function and therefore meant that the quadrate and articular would now only function in auditory function. So just looking at this quick rough sketch, just showing the double joint. So this blue is noting the quadrate and the yellow is noting the articular, and then the joint would just be formed right between them. So this would be the primary jaw joint, and this would be the secondary jaw joint. So this is noting the dentary, which is going to make up the entire lower jawbone, and this is the squamosal bone up here. So the secondary jaw joint was formed between them. And as you can see, because it's located higher up on the jaw, it can help in chewing much easier, as we know of our jaw today. So it's important to note that evolutionary history suggests that the lower jawbone increased in muscle attachments, like the jaw joints, in order to decrease the jaw element structures that resided in these bones, and therefore would increase the sound transmission due to the smaller bones. So those bones, the postdentary bones, which were in our case the quadrate and articular, once sat inside the dentary in tiny little grooves. But when the evolutionary shift occurred, which was triggered initially by the secondary jaw joint formation, these bones moved towards the middle ear. So the enlargement of the dentary is what led to these bones decreasing in size and shifting towards the middle ear. Again, this was allowed to happen because these bones, the quadrate and articular, only functioned in auditory function now. So lastly, I just want to talk about the evolution of the dentary, final thoughts, and how this led to the formation of the definitive mammalian middle ear. So figure 5E is just showing the mammal transitioning into having its enlargement of the dentary and separating those middle ear structures from the lower jawbone. So figure 5E is again showing ossified Meckel's cartilage, which the malleus is attached to its posterior part through the ossification, and again the incus is also linked to the malleus. So when you look at this figure, I just want to note between figure E and then figure F, you can see that the dentary will enlarge and change its structure or shape and push these bones out. So when you look at figure F, you can see that there's a definite change in structure, and this has enlarged upwards as well as this as well. So these middle ear bones that used to reside there were now shifted towards the middle ear and have become a separate structure from the jaw, and these were pushed then to the ear. So the definitive mammalian middle ear is defined by the full separation between the middle ear structures from the jawbone, which they have now done through the evolutionary shift. Finally, I want to highlight that the quadrate and articular were primary homologous structures to the incus and malleus. Their connection to the jaw originated from their connection to Meckel's cartilage, and through ossification, these bones remained attached to the posterior part, but were able to be separated due to the formation of the primary jaw joint. And later, the secondary jaw joint, which was formed through advantages in survival, led to the expansion of the dentary thus leading to the definitive mammalian middle ear. Thank you.